Hi everyone, my name is Benjamin, and in today's video we are going to talk about stablecoins, a fundamental concept in DeFi and serving as the cash layer of the on-chain economy. So in today's video we are going to cover what stablecoins are and how they are used, how Solana's token 2022 standard contributes to this, and finally build our own token using token extensions to simulate actual stablecoin behavior. And on top of that, all the codes will be available for download via our GitHub repository. For more information, you can always check out our official documentation or join our great Discord community. Both links will be in the description. And with that said, let's get started. Alright, so if you're new to DeFi, it's important to know some basics, and one of these basics is stablecoins. So what exactly are stablecoins? Now, basically, they are cryptocurrencies created to maintain a consistent value and price pegged to an underlying asset. And most stablecoins, they are pegged in value to fiat currencies such as the US dollar and the euro. Now, what does that mean? It means that if someone buys $100 worth of a stablecoin, 100 tokens are minted. And if that same person withdraws these $100, these 100 tokens, they are burned, primarily, of course, through authorized issuers and arbitrage mechanisms. Now, on the other hand, we have also cryptocurrencies such as Bitcoin and Solana, and they fluctuate in price, and they are not pegged necessarily to a fiat currency. And this makes them more attractive for investing and trading, of course. Now, stablecoins, on the other hand, they do not fluctuate as much as they follow a one-to-one connection to, for example, USD, which makes them ideal for transferring funds, making payments, or holding cryptocurrencies without exposing ourselves to these price fluctuations that come with assets like, for example, Bitcoin and Solana. Now, looking at Solana, we have two major stablecoins, and they are USDT and USDC, both of which try to maintain a consistent value equal to the US dollar. Therefore, the names, of course, USDT and USDC. In other words, one USDT or USDC equals to $1 US. Now, since 2026, we have also Pi USD and USD1, but most of the people, they are still using USDT and USDC. Now, this stability is mainly achieved by making sure that there is an actual equivalent in dollars for every USDT or USDC token issued. And this makes them fiat collateralized stablecoins. And that is because the collateral against these stablecoins is in fiat. Now, stablecoins, they don't have to necessarily be pegged against a fiat. A stablecoin in theory can be pegged against any other underlying asset. For example, a DAI. Unlike these fiat-based stablecoins, DAI is not backed by a fiat currency in a bank account, but rather by other crypto assets locked into smart contracts managed by the Maker protocol and the MakerDAO. Now, besides transferring funds or holding funds, stablecoins have several important benefits. They provide cheap and fast ways to transfer money internationally without having to wait days, making it a first choice for many remittance services. Now, besides that, stablecoins are also often used by investors and traders as a safe haven during market crashes to make sure that they can preserve the value of their assets when a lot of turbulence is happening within the markets and they need a way to peg their assets to a more stable asset really quick. Now, on top of that, stablecoins are also used in lending, borrowing, and yield-earning applications and offer a great array of possibilities to bridge the gap between DeFi and traditional finance, Web 2 and Web 3. So, stablecoins, in short, they offer us the reliability of traditional currencies combined with the transparency and speed of the Solana blockchain. Now, before we start building our own Solana stablecoin, it's good to understand some Solana core principles. So, what we are going to do first is cover the token 2022, also known as token extensions, which is Solana's new token standard, allowing us to add additional features to token mints and token accounts, meaning we can add on-chain rules, advanced control, and role-based access to our created tokens, which will help us make sure that our stablecoin is compliant. Now, before we start building that coin, let's recap real quick how tokens work on Solana. So when you create a token, you have a mint account, and this is the definition of the currency, you could say. Like the total supply is mentioned, the number of decimals, mint and freeze authorities, and also what token extensions are added. And there is only one mint account per token. Now, on the other hand, we have the token accounts, and this is where the actual tokens for that mint account are held. It acts actually be like a wallet. In short, it tracks the balance and points back to the mint account or the owner. Now, there are literally thousands or millions of token accounts because there is one for every user that holds that stablecoin. Now, all of this will be built on top of the built-in token program, which is called the SPL tokens program, and it takes care of things like creating mints, minting tokens, transferring tokens, and also burning them. Now, this is great for creating tokens, but it falls short for more advanced implementations such as stablecoins. And this is where we need this additional functionality, and that is where we will use these token extensions, also known as the Token 2022 program, which is of course backwards compatible with the SPL tokens program. Now, as we covered in a previous video, the Token 2022 program has over 15 different extensions it can add to tokens, and it is these extensions that adds powerful features to tokens. Now, a simple example is the memo transfer extension that requires a memo instruction immediately before any incoming transfer to that token account. And this enables, of course, all kinds of use cases, like for example, a required payment references before receiving tokens. Now you see, adding these Token 2022 extensions provide additional functionality that make our tokens extremely powerful. So let's create a simple stablecoin using the Token 2022 extensions. Alright, so this is our code base for today, and as a reminder, you can always download the code via our GitHub repository. The link will be in the description. But if you check out the README file, you will see here that it says it is a walkthrough of building a regulated style stablecoin on Solana using the Token 2022 program. And this will actually simulate real stablecoin behavior. As it says here, we're going to create a token with extensions that real fiat-backed stablecoins rely on. For example, metadata pointer, token metadata, default account state, we are going to set it to frozen. For example, if we have a token or a stable coin and a new user gets tokens, so a new token account is created, by default that account state will be frozen, meaning the funds in that token account cannot be moved, they cannot be transferred. And this can be, for example, a KYC gate. So every time we have users holding our tokens, we want to make sure that we know our customers, and once that is done, we can use some kind of hook. We can actually unfreeze these token accounts. So these are these features that makes these tokens really powerful. As you can see, permanent delegate, once again, we can use it for clawback. For example, if tokens are moved in a way that is not allowed or in a not a legal way, we can always claw back these tokens and we can remove the funds from certain token accounts. And also pausable config, meaning that we can stop the minting of tokens, the transferring of tokens, if there is an incident related to our stablecoin. So as you can see, these extensions, they are actually used in real world stable coins. As you can see here, these stable coins they rely on, so they are not just picked randomly. We're actually trying to simulate real stablecoin behavior. Then there are other scripts like the mint script, where we're going to mint tokens for our stablecoin. We're going to transfer them from one holder to another. We're going to burn them. We're also going to freeze and unfreeze them so that we can see what that implies. So if we freeze a token account, you will see that a holder can no longer send these tokens to another holder. We're also going to claw back. So if a transfer occurred that is not legal, then we're going to claw back, meaning we're going to take away these tokens. And then we have a pause mechanism and a resume mechanism. As I said, if an incident, for example, happens related to our stablecoin, then we can stop all the operations ongoing. So if you click, for example, on clawback here, you will see that there is a narrative where we say holder 2 received tokens that we, the issuer, have decided were illegitimate, and that's why we're going to do a clawback. So there is a brief explanation on why we have this functionality and how that could be used in a real world scenario. So on all these scripts here, as you can see, there is a brief explanation on why we do that, why it is set up that way. So it is all really documented well so that you understand what's going on. However, we are going to briefly look at all these scripts, and we're also going to run them and inspect the accounts so you can see what's happening. Also remember, we are going to derive key pairs from wallets that are within the project. As you can see here under wallet ID, we have a private keys that we are going to use, and these are for demo purposes. So don't send actual funds to these wallets, because everyone has access to these wallets and everyone can recreate these key pairs from these wallets. So you can play with them if you want on DevNet, and if you want to play with your own wallets, you can always change the private keys here if you want to do so. That's up to you, but other than that, never send funds to these wallets here that are part of the project. Alright, so with that out of the way, let's start by creating our stablecoin. And real quick, we have a config file here where we specify the RPC URL, so we're pointing to DevNet. And we can also set the name of our stablecoin. For now, we're using Vibe USD. This will be our stablecoin, and also the mint address once we created that stablecoin that we can add here. And then we can use that stable account address within the remainder of our other functions. So if we look at this create a stablecoin function, once again, all the information is here, so you can read it through that. It is describing which actual extensions we are going to use for this stablecoin. We covered that really brief once we were looking at the README, but you can read through it if you want once again. Now, we're not going to cover this in depth. The code is available for you. I just want you to understand what is happening, and then if you are interested, you can always check out the code and look at the nitty and gritty of what's going on behind the scenes. But what we are using here is, of course, a Solana kit. We're using the Solana program system and the Solana program token 2022, and then some imports that we do from our index here. The index holds some functionality to recreate our wallets from these private keys, and also the imports that we do here from our config that I just showed you. Now, all this is native Solana, so everything that we import here, all the functionality comes with these three packages: Solana kit, the system program, and the token 2022 program. So first of all, we're going to create our RPC and RPC subscriptions connection, because that is needed in order to talk to DevNet. And then, as you can see, we have that helper function here, load signer from file. Real quick, this is a function under index here in the wallet folder, and what that does, it takes these private keys from these JSON files and it turns them into actual signers or key pairs that we can use to sign our transaction. Then we are going to generate a mint for our actual stablecoin. We're going to calculate the space that is needed to create that stable coin, because of course, if we create a coin, we need to have a space, so we need to know how much LAMP ports we need to also add to that stable coin in order to make it rent exempt. So that's what we're doing here. We calculate that space, we set that space in a big integer number, and then we can use that once we create the actual instructions here to set the extensions to the token. And that's what we do here. Once again, all these functionalities, all these functions, they are imported via these the libraries here on top, as you can see. So if we open that one, the create account instruction that comes with the system, and all the others, they are imported here via token 22. So once again, if we look at what's happening here, we are actually creating these instructions that we can add to our transaction message once we are going to create our stablecoin. And that's what we do here. So we have a instruction to create the account itself, to create the metadata pointer, the default account state. As you can see here, we set it to frozen. We also have the permanent delegate, and the permanent delegate is our issuer. As you can see here, issuer is derived from, let's look real quick, from the issuer JSON. So that private key issuer here, so that is our issuer, and that is derived from that JSON file, and that is also our permanent delegate that we set here. And then we have, of course, the pausable config. Once again, we want to pause and resume everything that has to do with our stablecoin. And then we also have the final instruction to flip it into the live state, as it says here. So everything is described really well. And then we're also having a additional transaction here in order to write all that data into our created mint. Now then, we're creating a quick function here, send and confirm, and we're using the function send and confirm transaction factory, where we use our RPC and RPC subscriptions under the hook. And what this will do is send that transaction for us, and then it's going to try to confirm it under the hood using a RPC subscriptions connection, which is actually a WebSocket connection. Now then, we're fetching a latest block hash, which is needed once we are going to create our transaction message. As you can see here, that's what we do using pipe. So we create an empty transaction message using version version 0. We're setting the fee pay signer. Again, this is our issuer. We add that created block hash, so the one that we got here, the recent block hash, and then we append all the instructions that we just created here above using the function append transaction message instructions. And as you can see here, the mint account instruction, the metadata pointer, the default account state, permanent delegate, the possible config, and the init mint transaction. And then we're going to have that transaction here, the create mint transaction, and we're also going to send that. Remember, we're going to sign it first using the sign transaction with message signers, and then we're going to use that function that we just created here to send and confirm it. And we're also going to do the exact same thing for our second transaction. Once again, we get that latest block hash. We're going to build that transaction message, then we're going to sign it, and then also here we are going to send and confirm it. And then we're going to pull the transaction signatures, and then we're going to nicely output what just happened. So we're going to output the name of our stablecoin, the symbol, the decimals, and also the transactions that were used to create our actual stablecoin. So with that said, what we can do now is just open a new terminal by clicking terminal here, new terminal, and then we can just type npm run just like this and then create. And if we do that, we will see that our stablecoin will be created. So if everything went well for you, you will see a similar output here with the name Vibe USD, the symbol once again, the mint. So this is our mint. We have to copy that and also paste that into our config. So we will do that so we can use it in the remainder of our scripts. And then once again, we have our transactions here, as you can see, that were used to create our stablecoin, and of course assign all the proper metadata and all the information needed that we specified here in our script. So if we copy this mint now real quick, we can go to Solana, the Explorer, and I already have our accounts here open. So our issuer, I have the holders account, and I have the second holders account. So what we can do now is have a look at our actual token. So if we paste that mint address here, you can see that we now have a Vibe USD. Now, as you can see, there is no supply yet, but that's what we're going to do now. We're going to mint supply, and then we're also going to send that to our first holder, and then we will check out the first holder's tokens, and we will see that it holds an actual supply of the token. So let's do that now. All right, so back to our code, you will see that we have here a file called mint. So if you make this a bit bigger, this is the file that we will use to actually mint a supply for our stablecoin. And then we're also going to send that supply to our first holder. And that's what we do here. Once again, we import everything. We create these RPC connections. We derive our wallets. This time we're also having the first holder and the issuer once again, because it will sign for the transactions. And then we're going to set the amount that we want to have from our token. Then we are going to derive a associated token account for our first holder. And we do that by using the actual address or the public address from the holder's wallet, and also the token 2022 program address. So that's how we derive that associated token account. And again, we are going to create these instructions. So we're going to create a instruction to create that associated token account. That's what we do here. And then we're also going to tar that holder's account, because remember, all the token accounts that we are going to create, in this case a associated token accounts where we will send funds to, are frozen by default, because that is how it is set when we create our stablecoin. And that's what we do here. So we are going to create that instruction that will make sure that the token account that we're going to create is no longer frozen. And that's what we do here with the get tar account instruction, so we can append that to our actual transaction message. And then we are going to create a instruction to mint that new supply directly into the holder's associated token account. Now, once again, we fetch the latest block hash and we create our transaction message. So just as we did before, the transaction message itself, we set the fee pay signers, the latest block hash, and also here we append the instructions that we created. So we're going to create that holder's associated token account. We're going to make sure that it is no longer frozen, and then we're going to mint that supply straight into that account. And then we're going to send and confirm that transaction that we just created. And once again, we are going to fetch that transaction signature to then once again output it here nicely within our console. So what we can do here now is type npm run and then just mint like this, and this will mint these tokens and send them to our first holder's account. So that's what we can see here. So the holder, this is the first address, so it starts with whole and then 1, and then the holder's associated token account. So this is the actual wallet that we discussed that will hold the tokens and the transactions. So what we can do now is go back to our actual Explorer, and here we are looking at the first holder, and if we refresh here and then go to tokens, as you can see here we have that transaction. But if we go to tokens and we select detailed, you can see that we have now these 1000 tokens, as you can see, and we can also click on the account or the mint address itself, and if we do so, then you will see that we end up once again on that Vibe USD. And also here we can see that we have now a actual supply of 1000, and that is because we minted these 1000 tokens into the associated token account from our first holder. Alright, so let's have a look at the next function, which is just a simple transfer, and we're going to transfer some of our tokens to the second holder. So that's what we're going to do here. Once again, we import everything, and here we are going to derive our addresses or our signer better, and we're going to use the issuer, once again, the first holder and the second holder's wallet. Then we're going to derive these token accounts or these associated token accounts. Remember, we have the first one already from the actual sender, which is holder 1, and we're going to do the same for the receiver, which is the holder 2. So we're also going to have a associated token account that can hold these tokens for holder 2, and we're also setting the amount of tokens that we want to transfer from our stablecoin. Now what we have to do here is make sure that we of course create that associated token account for the second holder, but also tau it or unfreeze it, because remember, every token account that is created for this stablecoin is by definition, by default, frozen. So we have to make sure that it is unfrozen as well. Then we're going to have a transfer instruction, and we're going to do the same exact thing here. So we're going to create that transaction message, we fetch that latest block hash, and then we're going to send and confirm that transaction. And then finally, once again, we're going to output the amount that we have transferred from our holder 1 to our holder 2, and also the transaction. And that we can do simply by typing npm run transfer. And if everything went well, as you can see here, we have our from, to, and then that transaction. So if we go back to Explorer, we have this first account here, so the holder 1. We can also refresh that, and then we will see that we no longer have these 1000 tokens. And then you can see that we no longer have these 1000 tokens, but we have 750 now. And if we go to the second holder's wallet, so if we refresh this, and then we go to tokens, you will see that we here have 250 tokens. However, our supply is just the same as before. They are transferred from one holder to another, but the supply in total is still 1000. Alright, so let's clear our terminal real quick and have a look at the next function, which is burn. So what it says here is holder 1 burns 100 VUSD. On chain, the burn instruction does two things. So it's one atomic step. So it will deduct 100 tokens from holder 1's associated token account. And then it will also decrement the mint supply from our stablecoin. Now here it says in a real stablecoin product, this is the on-chain side of redemption, where the user sends tokens to the issuer's burn flow, and the issuer burns them. And off-chain, the issuer will wire fiat back into the user's bank account. So this is actually what happens when a user withdraws these tokens in order to keep our actual supply equivalent to the amount of tokens that has been purchased or withdrawn. So that's what we do with this burn function here. And we can test it real quick. We can type npm run burn, just like that. This will start the burning of 100 tokens. So if we go back to our holder 1 and we refresh the page, then we can see we no longer have these 750 tokens, but we now have 650 instead. And if we click on the mint address, also here we can see that we will no longer have 1000 tokens, but 900 instead. So our current supply has also been decreased with 100. And that is exactly what we expect. All right, so what we have next and what is remaining are these administrator actions that can be done by the issuer. Like for example, freezing accounts, towing accounts, like unfreezing them, clawbacking the funds, also pausing and resuming. So these are exactly the same setup as the previous files. They are instructions that are being created, and then they are set into a transaction message. The transaction message is assigned, and then it is sent and confirmed. But just for the demo purpose, I will run through them, and then we will also check out in the Explorer what actually happens. So freezing, what we can do here is typing npm run freeze, and what that will do is freeze the first holder's account. So if we click on freeze, so as you can see here, what it says, freezing a token account is actually the real world sanctions enforcement. So after this transaction lands, so after we run that freeze instruction, the holder 1 can no longer send tokens out of his associated token account, and nobody can send tokens into this account either. So incoming transfers also fail against a frozen account. So what we can do now is type npm run freeze, and then this account, holder 1's associated token account, is frozen. So if we run now that transfer command once again, npm run transfer, so if we look at that, this should be denied. As you can see here, it says account is frozen, and that means that the first instruction where we froze the account actually worked. What we can do now instead of transfer is type tau like this, and then we are going to unfreeze that first account. So that's what we do here. That also landed, and if we clear the terminal now real quick, what we can do now is type transfer once again, and then you will see that the actual transfer went through. So we can freeze the account, and if we transfer, then that is denied as we saw, and then we can tau the account, or we can unfreeze it, and if we do that, then it is actually able to send and receive these funds once again. Now clawback, we can have a look at that real quick. So the narrative here is that the holder 2 received tokens that we, the issuer, have decided were illegitimate, meaning that the tokens that were sent, for example, in the second transfer, were not legal. So what we can do as the issuer is remove these tokens. So if we go back to our Explorer, and if we have a look at our second holder's wallet, so we can see that holder 2 now has 500 tokens from our stablecoin. So what we can do is actually clawback. So what we type here is npm run clawback, and we can check also how much tokens we are going to take back. I think we specified that here. So the amount, instead of 250, let's do 300. We save that, and then npm run clawback. This will take away these tokens from that actual holder 2 account. So if we go back now and we refresh this page, you will see that we no longer have this 500, but we have 200 tokens. And if you look at the details, we can also click on that mint address. Now what you will see here is that we have these 900 supplies still, and that means that once we claw back these tokens, they are not burnt. They're actually stored in a associated token account from the issuer, and that's what we can see here. So issuer associated token account, if we look at this address now, you will see that these 300 tokens that were taken away from that second holder are now residing in our own associated token account. So they are not burnt, they are just taken away. Maybe we can send them back if we need to do some investigation. So that is actually the power of the clawback that we just heard it. Now we also have pause and resume. Once again, if we type npm run pause, this will pause all the operations for our stablecoin. So if this lands, what we can type here is npm run, for example, transfer. Also this should fail because all operations, as you can see, transferring, minting and burning is paused on this mint. We as the issuer, we as the authority of the stablecoin have paused all the operations, and what we can do now instead of pausing is resume. So we can type npm run resume, and if this transaction lands, we should be able to transfer tokens once again. So that's what we do here. So npm run transfer, and also that transaction lands once again. Alright, so that's it for today. I hope that this code base shows you how you can create a stablecoin using Solana and the Token 2022 program. It offers a lot of powerful features that we can actually use to create a stablecoin. Of course, there is off-chain logic that is needed to make this an actual stablecoin, like for example, the KYC part and also the withdrawal of the funds back to the actual user's bank account. But Solana has a solution in place that handles all the on-chain logic if it comes to creating stablecoins. Once again, all the code is available for download via our GitHub repository. You can find the link in the description. That's it for today. Subscribe to the channel, like this video, and I'll see you in the next one.